Binary Star, Part 2 of 2. From Wikipedia, the free encyclopedia. http://en.wikipedia.org. Section 3. Binary Star Evolution. Formation. While it is not impossible that some binaries might be created through gravitational capture between two single stars, given the very low likelihood of such an event and the high number of binaries, this cannot be the primary formation process. Also, the observation of binaries consisting of pre-main sequence stars supports the theory that binaries are already formed during star formation. Fragmentation of the molecular cloud during the formation of protostars is an acceptable explanation for the formation of a binary or multiple star system. Mass transfer and accretion. As a main sequence star increases in size during its evolution, it may at some point exceed its Roche lobe, meaning that some of its matter ventures into a region where the gravitational pull of its companion star is larger than its own. The result is that matter will transfer from one star to another, either being absorbed by direct impact or through an accretion disk. The mathematical point through which this transfer happens is called the first Lagrangian point. It is not uncommon that the accretion disk is the brightest and thus sometimes the only visible element of a binary star. If a star grows outside of its Roche lobe too fast for all abundant matter to be transferred to the other component, it is also possible that matter will leave the system through other Lagrange points, thus being effectively lost to both components. Since the evolution of a star is determined by its mass, the process influences the evolution of both companions and creates stages that cannot be attained by single stars. Studies of the eclipsing ternary algal led to the algal paradox in the theory of stellar evolution. Although components of a binary star form at the same time, and massive stars evolve much faster than the less massive ones, it was observed that the more massive component, algal A, is still in the main sequence, while the less massive algal B is a subgiant star at a later evolutionary stage. The paradox can be solved by mass transfer. When the more massive star became a subgiant, it filled its Roche lobe and most of the mass was transferred to the other star, which is still in the main sequence. In some binaries similar to algal, a gas flow can actually be seen. Runaways and novae. It is also possible for widely separated binaries to lose gravitational contact with each other during their lifetime as a result of external perturbations. The components will then move on to evolve as single stars. A close encounter between two binary systems can also result in the gravitational disruption of both systems, with some of the stars being ejected at high velocities, leading to runaway stars. If a white dwarf has a close companion star that overflows its Roche lobe, the white dwarf will steadily accrete gases from the star's outer atmosphere. These are compacted on the white dwarf's surface by its intense gravity, compressed and heated to very high temperatures as additional material is drawn in. The white dwarf consists of degenerate matter, and so is largely unresponsive to heat, while the accreted hydrogen is not. Hydrogen fusion can occur in a stable manner on the surface through the CNO cycle, causing the enormous amount of energy liberated by this process to blow the remaining gases away from the white dwarf's surface. The result is an extremely bright outburst of light, known as a nova. In extreme cases, this event can cause the white dwarf to exceed the Chandrasekhar limit and trigger a supernova that destroys the entire star, and is another possible cause for runaways. A famous example of such an event is the supernova SN 1572, which was observed by Tycho Brahe. The Hubble Space Telescope recently took a picture of the remnants of this event. Section 4. Use in astrophysics. Binaries provide the best method for astronomers to determine the mass of a distant star. The gravitational pull between them causes them to orbit around their common center of mass. From the orbital pattern of a visual binary, or the time variation of the spectrum of a spectroscopic binary, the mass of its stars can be determined. In this way, the relation between a star's appearance, temperature, and radius, and its mass can be found, which allows for the determination of the mass of non-binaries. Because a large part of stars exist in binary systems, binaries are particularly important to our understanding of the processes by which stars form. In particular, the period and masses of the binary tell us about the amount of angular momentum in the system. Because this is a conserved quantity in physics, binaries give us important clues about the conditions under which the stars were formed. In a binary system, the more massive star is usually designated A, and its companion B. Thus, the bright main sequence star of the Sirius system is Sirius A, while the smaller white dwarf member is Sirius B. However, if the pair is very widely separated, they might be designated with superscripts, as with Zeta Reticuli. Research findings. It is believed that a quarter to half of all stars are in binary systems, with as many as 10% of these systems containing more than 2 stars, ternary, etc. There is a direct correlation between the period of revolution of a binary star and the eccentricity of its orbit, with systems of short period having smaller eccentricity. Binary stars may be found with any conceivable separation, from pairs orbiting so closely that they are practically in contact with each other, to pairs so distantly separated that their connection is indicated only by their common proper motion through space. Among gravitationally bound binary star systems, there exists a so-called log-normal distribution of periods, with the majority of these systems orbiting with a period of about 100 years. This is supporting evidence for the theory that binary systems are formed during star formation. In pairs where the 2 stars are of equal brightness, they are also of the same spectral type. In systems where the brightnesses are different, the fainter star is bluer if the brighter star is a giant star, and redder if the brighter star belongs to the main sequence. Since mass can be determined only from gravitational attraction, and the only stars, with the exception of the Sun and gravitationally lensed stars, for which this can be determined are binary stars, these are a uniquely important class of stars. In the case of a visual binary star, after the orbit has been determined and the stellar parallax of the system determined, the combined mass of the 2 stars may be obtained by a direct application of the Keplerian harmonic law. Unfortunately, it is impossible to obtain the complete orbit of a spectroscopic binary unless it is also a visual or an eclipsing binary. So from these objects, only a determination of the joint product of mass and the sign of the angle of inclination relative to the line of sight is possible. In the case of eclipsing binaries, which are also spectroscopic binaries, it is possible to find a complete solution for the specifications, mass, density, size, luminosity, and approximate shape of both members of the system. Science fiction has often featured planets of binary or ternary stars as a setting. In reality, some orbital ranges are impossible for dynamical reasons. The planet would be expelled from its orbit relatively quickly, being either ejected from the system altogether or transferred to a more inner or outer orbital range, whilst other orbits present serious challenges for eventual biospheres because of likely extreme variations in surface temperature during different parts of the orbit. Detecting planets around multiple star systems introduces additional technical difficulties, which may be why they are only rarely found. Examples include PSR B16220-26C and HD 188753AB, the latter being the only planet observed orbiting a ternary system as of 2006. Section 5. Multiple star examples. The large distance between the components, as well as their difference in color, make Albireo one of the easiest observable visual binaries. The brightest member, which is the 3rd brightest star in the constellation Cygnus, is actually a close binary itself. Also in the Cygnus constellation is Cygnus X1, an X-ray source considered to be a black hole. It is a high-mass X-ray binary, with the optical counterpart being a variable star. Another famous binary is Sirius, the brightest star in the nighttime sky, with a visual apparent magnitude of -1.46. It is located in the constellation Canis Major. In 1844, Friedrich Bessel deduced that Sirius was a binary. In 1862, Alvin Graham Clark discovered the companion, which is called Sirius B. The visible star is then known as Sirius A. In 1915, astronomers at the Mount Wilson Observatory determined that Sirius B was a white dwarf, the first to be discovered. In 2005, using the Hubble Space Telescope, astronomers determined Sirius B to be 12,000 kilometers in diameter, with a mass that is 98% of the Sun. The system plays a vital role in the Dogon culture. An example of an eclipsing binary is Epsilon Aurigae in the constellation Auriga. The visible component belongs to the spectral class F0. The other eclipsing component is not visible. The next such eclipse occurs from 2009 to 2011, and it is hoped that the extensive observations that will likely be carried out may yield further insights into the nature of this system. Another eclipsing binary is Beta Lyrae, which is a contact binary star system in the constellation of Lyra. Its two-component stars are close enough that material from the photosphere of each is pulled towards the other, drawing the stars into an ellipsoid shape. Beta Lyrae is the prototype for this class of eclipsing binaries, whose components are so close together that they deform by their mutual gravitation. Other interesting binaries include 61 Cygni, a binary in the constellation Cygnus, composed of two K-class orange main sequence stars, 61 Cygni A and 61 Cygni B, which is known for its large proper motion. Procyon, the brightest star in the constellation Canis Minor and the eighth brightest star in the nighttime sky, which is a binary consisting of the main star with a faint white dwarf companion. SS Lacerti, an eclipsing binary which stopped eclipsing, and V907SCO, an eclipsing binary which stopped, restarted, then stopped again. Algol is the most famous ternary, long thought to be a binary, located in the constellation Perseus. Two components of the system eclipse each other, the variation in the intensity of Algol first being recorded in 1670 by Geminiano Montanari. The name Algol means demon star from Arabic, which was probably given due to its peculiar behavior. Another visible ternary is Alpha Centauri in the southern constellation of Centaurus, which contains the fourth brightest star in the night sky, with an apparent visual magnitude of -0.01. This system also underscores the fact that binaries need not be discounted in the search for habitable planets. Centauri A and B have an 11 AU distance at closest approach, and both should have stable habitable zones. There are also examples of systems beyond ternaries. Castor is a sextuple star system, which is the second brightest star in the constellation Gemini, and one of the brightest stars in the nighttime sky. Astronomically, Castor was discovered to be a visual binary in 1719. Each of the components of Castor is itself a spectroscopic binary. Castor also has a faint and widely separated companion, which is also a spectroscopic binary. Section 6. Fictional usage. Many writers in the science fiction genre have explored the possibilities of binary star systems. One of the more famous examples is the planet Tatooine in the Star Wars movies, which orbits the two stars Tatu-1 and Tatu-2. Other instances include the anime series Simoon and the 1994 computer game Little Big Adventure, the latter set on a planet stabilized between two stars. In David Weber's Honorverse, the Manticore system is a binary star with 3 habitable planets, 2 of them, Sphinx and the capital world Manticore, orbiting Manticore A, and 1, Griffin, orbiting Manticore B. There are also fiction uses of even more exotic stellar configurations. In the Star Trek Enterprise episode Singularity, the Enterprise visits a ternary star system, as do the heroes of Futurama in the episode My Three Sons. Isaac Asimov's renowned short story Nightfall is set in a six-sun system, an astronomically implausible situation arranged for literary effect. This concludes Part 2 of Binary Star. This sound file and all text in the article are licensed under the GNU Free Documentation License, available at www.gnu.org/copyleft/fdl.html.